have done inequalities in the past, there are some rules that go with inequalities. If you divide an inequality by a negative, what happens to the sign?
It changes.
Yeah, it flips, it changes, right? So if it was less than, it becomes greater than. So you got to remember that when you're doing your homework tonight, okay? Because we're going to get things into the y equals form, but instead of there being an equal sign, there's going to be an inequality sign. Yes. This is 8.9. Oh, sorry.
Oh, this is 8.9?
It's 8.9. Okay. So 8.9 is graphs of linear inequalities. Okay. So a linear inequality replaces the equal sign with less than, greater than, less than or equal to, or greater than or equal to. Okay. We're going to talk about how to graph them. They graph the same way as linear functions, but we just have to tweak a couple little things. Okay. So first thing is, we want to tell whether the ordered pair is a solution of this linear inequality. What do you think we're going to do with 0, 1? Plug it into the equation. So I'm going to say 2 times 0 minus 3 times 1 is less than 6. What? Stop. Just relax. It's good. What's 2 times 0? 0. What's negative 3 times 1? So you get negative 3 is less than 6. Is that a true statement? Is negative 3 less than 6? Yes. So this is a solution. Okay? Now we're going to plug in for negative 2, because here's the deal. On inequalities, you can have a lot of solutions because you're going to shade these areas. We're going to look at it. Okay? So here I'm going to plug in 4. 2 times 4 minus 3 times negative 2 less than 6. What's 2 times 4?
8.
What's negative 3 times negative 2?
6.
Positive 6. So then what's 8 plus 6?
14.
Is 14 less than 6?
No.
So it is not a solution.
Not a solution.
Okay, no solution.
Do we do that?
Josh, it's exactly what we did on our last homework. You're plugging solution points into an equation, and if the statement is true, yes, it's a solution. If the statement is false, no, it's not a solution. Okay? You can do check marks and X's. I don't care. Okay? Let's talk about how we graph these, okay? Graph of a linear inequality. It means all points in a coordinate plane that represent the inequality. So if you have this inequality right here, see this? 2x minus 3y is less than 6. Okay? The first thing you want to do is get y by itself. Just like we do when we graph linear equations. Get y by itself. Okay? So I subtract 2x from both sides. I get negative 3y is less than negative 2x plus 6. You divide by negative 3. Now, that means you have to flip the sign. So I get y is greater than 2 over 3, because the negatives cancel, yes? X minus 2, because 6 divided by negative 3 is negative 2. Now look, this is in mx plus b form. Okay? So when I go to graph, I start by graphing at negative 2, my y-intercept. Okay? I go up 2 over 3 for my next point. Maybe if this, oh no, I did do that right. I go up 2, 1, 2, over 1, 2, 3 for my next point. Okay, now here's the deal. Do you see how my line is dashed?
Oh, yeah.
Why is it dashed and not solid?
Solid.
It's a trick question. I don't know if you know the answer to this. Just, okay, listen. You get a dashed line if this sign is greater than, or if this sign is less than. If it says less than or equal to, or greater than or equal to, I have a solid line. Okay? Dash, dash, solid, solid. Okay? So when you're graphing these inequalities, you graph it like a linear function, and then you decide if it's dashed or solid. Okay? That's step 2. So step 1 is getting it into this form. Step 2 is graphing this line. Step 3, do you see how I have shading? Okay, here's how you do step 3. Step 3, you're going to plug in a set of points. Okay? I plugged in 0, 0. The set of points cannot be on this line. 0, 0 is always the easiest one to plug in if it's not on that line. Pick 0, 0 if it's not on that line. Okay, I plug 0 into y, I plug 0 into x. So I get 0 is greater than negative 2. Is that a true statement? Yes. So if it's true, you shade where 0, 0 is.
Say that again.
Okay, if this statement is true, 0 is greater than negative 2. I shade where 0, 0 is. Do you see 0, 0s right here?
Yes.
So I'm shading everything on this side of the line. Okay? If it wasn't true, where would I shade? I would shade on the other side of the line. Okay? So we're going to practice graphing 3 of these so we can practice shading. Okay? Now, look at this one. Y is greater than or equal to 2x plus 4. Where do I start my graph? At positive 4. What's my slope? 2. So I'm going to go where? Up 2 over 1. And what am I going to do with this line? Is it going to be solid or dashed?
Solid.
Solid.
Yeah.
Okay, solid line. Now, that's the easiest part. Now we have to check to see where we shade. What point do you want to plug in? 0, 0. So I'm going to say 0 is greater than or equal to 2 times 0 plus 4. Is 0 greater than or equal to 4?
No.
No. 0 is not greater than or equal to 4. It's less than, right? So if 0, 0 is here, then I'm not shading this way. I'm going to shade opposite. So you're going to go like this. And look, these are all the solutions that make this true. So if I want to know what solutions could make this true, I could say, oh look, negative 2, positive 3 makes that a true statement. I could say, oh, negative 4, 0 makes that a true statement. I could say, what is this, 5? I could say negative 5, 5 makes it a true statement. You can pick any points that's in that shading. It will make that statement true. Okay? So that's why I have all points in a coordinate plane, because it's going to be a lot of options for me to choose from. Okay? How do I graph x is greater than 3? Okay, Carter, attempt.
You would start at 3.
On what axes?
The y axis.
Think about it. Does it say x or y? X. So that means I'm going to start on what axis? The x-axis. So I go to 3 on the x-axis. Okay? Which way does my line go? Vertical or horizontal?
Horizontal. Vertical.
Vertical. Remember, when you're graphing something on that axis, it has to go opposite. Okay? So vertical. Dashed or solid line?
Dash.
Dash.
Yeah.
So I have a line that looks like this. Now, tell me, do I shade on the left or right? What makes that statement true? X is greater than 3. Right, because the numbers have to be larger than.
Wait, say that again.
Because I graph on the right because the numbers have to be larger than 3. So a 4 makes that statement true. A 5 makes that statement true. A 2 does not make that statement true. Okay? So I shade where the statement becomes true. Okay. Look at this one. Where do I start this graph at? Negative 2 on what axes?
Y.
Y. Okay. Dotted or solid line? Horizontal or vertical? Horizontal. I cannot draw a line through y equals negative 2 vertically. That doesn't work. Okay? It has to be horizontal. Now, what statement would make it true? It says y is greater than or equal to negative 2. Okay, so if I shade which way? Up or down? All of these numbers will make this statement true. Okay? So on your homework tonight, when you are graphing, I need you to see dotted and solid lines. I'm checking for those. I need to see shading on all of your graphs. Anytime it is an inequality, you are shading and you're giving me a dotted or solid line. Understood? Okay, let's talk about the word problem, and then we will be done with this lesson. Okay, so this lesson is very similar to everything we've done. We're plugging points in. okay? And we're resolving for y. We just added dashed or solid lines and we added shading, okay? You have 100 pounds of clay to use for making bowls and vases. You need 5 pounds of clay for each bowl, 2 pounds of clay for each vase. Guys, focus. A lot of you owe me homework for today, so focus. Write an inequality describing the possible numbers of bowls and vases that you can make. So I need to write an inequality for this, okay? What are the numbers I have to work with already?
105 and 2.
105, 2. Good, Carter. 105 and 2. So what do you think? What do you think that is my, what do you think, do I have to use all the clay? Does it tell me I have to use all the clay? No. So my inequality is going to then have less than or equal to 100. Does that make sense? Because I can use all the clay or I can use less than 100 pounds because it doesn't tell me I have to use it all. Okay? How can I set up an equation from there?
It would be like 5x plus 2y.
Beautiful. 5x plus 2y. Okay? So here is an equation of what that will look like. Hey, Carter might be able to do it, but you might not be able to. Maybe you should pay attention. Josh, computer down. You don't even need it open. E, are you taking notes or what are you doing?
Yeah, we were taking notes. Slide your computer up, sir.
Okay. So you get this equation of 5x plus 2y is less than or equal to 100. Now, it wants me to graph this. So what do I need to do to this equation? Guys, stop talking. I need to subtract 5x first, right? So that I get 2y is less or equal to negative 5x plus 100. Now what?
Then you divide by 2.
Divide by 2. And does the sign change?
Yes.
No, I did divide by negative, so it stays. Y is less than or equal to negative 5 over 2x plus 50, right? Half of 100 is 50. Okay. So my graph is going to start where? At positive 50. Let's just mark this as 50, okay? And what's my slope? What's my slope? Down 5 over 2. So let's make this, let's just count by 5s. How's that sound? Okay, we'll pretend like this is beautiful. Remember on your graph, you have to label for me so I know what you're counting by. Okay, you really, I know you know how to do this. You'll be fine. That was your cues. Jason and Craig, stop. I didn't say you were talking to him. Both of you are just making noises and not controlling your body. You're hitting yourself with a folder. You're flailing around like a crazy person. Just stop. Just stop. Okay, so you're going to go down 5, right? And we're going to go over 2. Is it a dotted or a solid line? Solid line. So my line is going to go like this, right? Now, let's talk. We have to shade, yes? Okay, so let's plug in what number? 0, 0. Is 0 less than or equal to? Yeah, is 0 less than or equal to 50? Is 0 less than 50? Yes. So I'm going to shade this whole area. Now listen, why am I not shading into the negatives?
Because it's not negative.
Because you don't want to.
Right, I can't use less than 0 clay, right? Like that.
Wait, so if when we do that, are we allowed to use like a crayon or something?
Yeah, you guys can use highlighters, you can use colored markers. I don't care what you use. That's fine. Use pens, use pencils, whatever you want. Okay? So listen. Stop. We're not done. Okay? So now, that's graphing it. First we came up with the equation, then we graphed it. The last part says, give 3 possible combinations. Meaning, give 3 possible solutions of this graph. What are 3 ways we could use the clay? Okay, you could use 1, what? What do you, it's going to be like 1, if we're counting by 5s, it's probably going to be like 120 or something like that. Does that make sense? Okay. So you could do like that. Guys, stop talking. Yes.
So
You would pick 3 points inside that shaded area. Okay, I'll put it on Power School.
Emmanuel.
Yeah, you.
Graph only.
Oh, I will.
Jason, take out your card. I'm about ready to mark it again. Keep your mouth shut. Yeah, you would just pick 3 points inside here. That's why I want you to graph it on graphing paper too, because then you can pick a better point. Does that make sense?
Yeah.
It'll be easier to be like, oh, that's exactly this. I can pick this point right here, 0, 50. I can pick wherever it crosses down here as like 10, 0, okay? You can pick any points. They gave 3 examples in the book that says 5, 20, 10, 10, 20, 0, okay? Any 3 points in that shaded region you can choose. So everybody's answer could be different, okay? So don't freak out if your neighbor's is different than yours. That's okay. As long as you picked 3 points in that shaded region, cool. Okay? That is what 8.9 is about. We are going to start homework here. Maybe. If I can type.
Did you